Yo, it's Teta time. Yeah. So today we're gonna be looking at some physical science. It's getting physical. So science is very cool, especially physical science. So first, I want to dive into the world of heat transfer. So there's three different types. Let's talk about them right now. So first, we have conduction. And so conduction is the transfer that takes place between objects when they directly contact each other. So for example, if you get a bag of M&Ms, what happens as soon as you put those M&Ms in your hand if you leave them for a little bit? Yeah, they start melting. Candy melting in your hand is an example of conduction because what's happening is the heat is actually leaving your body because you are hot. And it's leaving your body and it's melting that candy in your hand. That chocolate's like, oh, melting. And so that's what's happening in your hand. That's called conduction. But see, then we have this other cool type called convection. And so convection is the transfer of heat that happens within fluid. So for example, you guys know me, you know Mr. Tedder, I love me a cup of coffee. So if I'm carrying around coffee and it's really hot, you'll see steam. That's an example of convection. But what's cool about a cup of coffee is it actually has conduction and convection happening at the same time. So the cup around the coffee gets hot. That's an example of conduction. But the steam rising is an example of convection because it's happening within the fluid. So what's happening is the hot air is rising off of the fluid and cold air is replacing it. That's convection. You guys remember, land and sea breeze, hot air replaces cold air, that sort of thing. That is convection. Then we have this other type called radiation. This is the transfer that occurs through electromagnetic waves without involving particles. And so out of all these, radiation is the fastest. It's got the fastest heat transfer. Convection is the next, and then conduction is the slowest. So those are the three types of transfer. Now, if we're talking about transfer, what also happens with heat transfers is sometimes they can change an object. And that's when we get into the world of physical and chemical change. Let's start with physical. Physical change is when the material involved in the change is structurally the same, but it may look a little different. So the types of physical change are, of course, texture, shape, temperature, and a change in matter. So a physical change is when something changes, but it's still the same thing. So for example, that right there is an example of physical change. I just went from wearing the navy to the gray, but I'm still Mr. Tedder. So my appearance changed, but I'm still the same person. That's physical change, when the object changes its appearance or temperature, but it's still the same thing. So for example, when water goes to ice, it's still H2O, it's still water. It's just in a different form. That's an example of physical change. Now, chemical change is completely different. So chemical change is a change that occurs when the composition of the object changes completely. And by composition, we mean it becomes something brand new. It becomes a different object altogether. So chemical change. If I put wood in a fire to burn, it changes completely. It turns to ashes. It's a different material. It's a completely different substance. This is chemical change. So physical change changes the physical appearance, changes the temperature, it changes, but it's still the same thing. So if you're looking at an object and you're trying to figure out, is it a chemical or physical change? Just think, is it the same thing? Is it the same object? If it's the same object, it's physical change. If it's a completely new thing, it's chemical. And so changes happen all the time around us. Something else that happens all the time is force. Force right now is pushing me down to the ground. This thing called gravity. So gravity is pushing me down and it's like, but it's really not that bad. But see, force is all around us. It helps us speed up, it helps us slow down, it helps keep things balanced. And so one of the major type of forces is called friction. So you guys did a lab, but if I was to roll a marble down a hill, let's say I was rolling it on like sandpaper, well, that's going to create more friction than if I just rolled it on glass. Glass is not going to have that much friction to the marble, so the marble is going to be able to go faster with less friction. So force, if I want to slow something down, pump the brakes, I need to apply friction. Brakes is a great example. If I were to go out in my car and I'm going up to 100 miles per hour, don't do that, and I want to slow down, I pump the brakes, I push the brakes, and the brake pad causes friction, which causes me to slow down. Friction helps us slow down. Gravity helps us stay here on Earth. Thank you. Because I don't want to be floating up in the air. So that is how we do force with friction. Now, talking about speed, you guys can calculate speed using a formula. You guys learned about that formula. Distance divided by time. So let's say Mr. Tedder's out for a run. And I can run 100 meters in 15 seconds. Well, to find speed, I do distance divided by time. So I take my 100 meters and I divide it by my 15 seconds, and I see that I can do 6.67 meters per second. That's booking it. The fastest Olympian is usually around 9 something. I'm not an Olympic athlete, but 15 seconds for a 100 meter dash is not that slow. Well, maybe. But that's how you calculate speed. The big thing here, do speed, you do distance divided by time. And then when we talk about distance and times, we have these things called distance and time graphs, where you have time at the bottom and distance over to the side. So the steeper the graph, the faster I'm going. So I'm covering way more distance in a shorter amount of time. So if it's flatter, I'm going slower. But if it's steeper, I'm going faster. And if it's straight out flat, I'm at a completely stop. So if I'm moving, and maybe I speed up, it's gonna be like this. But if I come to a complete stop, it's gonna be flat. And then if it goes down, like back towards the bottom line, which we call the x-axis, I'm going back to where I started. So distance versus time graphs help us chart the travel somebody goes. Let's say I'm leaving right here at Jones and I'm going to Walmart. All right, so you're gonna track my speed. Maybe I go faster here on Riverside, and then I go slower when I pass by the police department, and then maybe I go faster when I get to 601 where Wendy's and stuff is. And so my graph would be like steep, not so steep, steep again, and then I get to Walmart, it's gonna be a completely flat line because I stopped at Walmart. And then when I come back, it's gonna be the same thing. So maybe it's steep, a little bit slower, steep again, but it's going down. It's coming back down to the x-axis. So that's how distance versus time graphs work. So now, that is a bunch of stuff for physical science, but physical science is so cool because it's our hands-on. It's the stuff around us every day. You guys don't realize how important physical science is because you face it every day, from plugging in something to driving here with your parents to riding in a bus. Every day we are faced with physical science of force, physical chemical change, all those things. So I hope this video helped you. Ted time out.